Okay, I said there was going to be a lot of 13.5. This is actually from a part of your book that's between 13.5 and 13.6. It's called 13.5 Extended. And believe it or not, we are going to go back to some more 13.5 after this. But this is just about two-way frequency tables. It's sort of a big deal in the Common Core, and it's a big deal in AP Stats. And you see these in real life a lot. So it's going to help with our ideas about independent and dependent events also. Okay, so what a two-way frequency table is just it's called two-way because there's rows and there's columns, and the rows stand for kind of one variable about the situation, and the columns stand for a different one. So in a table like this, it shows this one's about the Titanic. It's about different classes of tickets you could have had on the Titanic. I know you don't have this on your worksheet, but I put this one here as an example. The types of tickets and whether or not the person survived the sinking. So in the first class, there were 325 total first class passengers. 203 of them survived, 122 died, and so on. So that's how you read that. And what's nice about this one is they included these totals for you. They don't have to include those. You may have to fill those out, but those are really important to have. These start to fall into denominators when we start to look at probabilities. These are called the marginal frequencies. And again, they may be there, they may not be there. You may only have the stuff in the middle, which is called the joint frequency in each one of these cells. Maybe you can understand why this is called joint frequency. Like this 178 here, it's kind of the intersection of two categories at once. This 178 represents people who were in third class and survived. So that's why it's called joint, because it's two things together. This 885 is all the crew. This 1490 is all of the people who died, and that's pretty easy to figure out. Okay, so here's an example. We have problems like this where they just give you some of the numbers in the table and you have to figure out the rest. Well, this total 69 here, of course, that has to be the sum of all the people attending the prom. So you can figure out how many juniors were supposed to be at the prom, because we know there were 44 seniors and 69 total, so that's really just a matter of subtraction. So that's what, 5, 40, 50, 60, 25. And, oh gosh, then what do we do? It's kind of like a little crossword puzzle, actually. I could fill that out. Well, now I know about all the juniors. I knew juniors not attending the prom was 59. Juniors who did attend the prom was 25. So the next thing I can fill in is this. And 25 plus 59 is just 70, 84. I could fill in these marginal things because I know that the total is 160. So this has to be 76, so that is 160. This has to be 91 for this to add up to 160. And this sum has to work. It's like those magic square problems you did like in third grade or something, where the things have to line up and add together, but they don't have to be any particular, they don't have to meet any other requirements. The sums just have to work out. So, all right, so if this is 91, this is 59. How many had to be here? I think 32. And as a check, 44 plus 32 actually equals 76, so that's good. So the rows and the columns all add up correctly to get to this one grand total of 160 people. All right, so that was part A. Fill that out. Part B, find the probability. And here's the fun part. Just reading stuff out of the table. Find the probability that a randomly selected student from the sample is. All right, so here's the people, here represents in their smallest categories. The joint frequency part of the table is this part. Everything outside of here is totals. It's kind of a good idea to keep that separate in your mind, I think. Find the probability that a randomly selected student from the sample is a senior. All right, so we're talking about randomly selected student from the sample. That means these came out of 160 people. So out of the 160 people at the prom, how many of them were seniors? Well, we just look at the total number of seniors. That was 76. Yeah, we should probably reduce that. I can reduce that a lot, can't I? This is 19 out of 40, I think. All right, a junior not attending the prom, a junior not attending the prom. So again, we're talking about randomly selected people out of the entire prom, so that's 160 people total it could have been. How do we know that randomly selected person was a junior who did not go to the prom? Okay, that's this. It has to be in that 59. That does not reduce. Not attending the prom, well, not attending the prom was a total of 91 out of the 160. I don't think that reduces either. Find the probability that a senior from the sample is attending the prom. Okay, so we know we have a senior. Find the probability that a senior from the sample. Okay, so now it's like we're talking about a smaller sample now. We're actually talking about among the seniors. What's the probability that a randomly selected senior, so I know I'm in here already, is attending the prom? So that's 44. That's 44 out of the 76 seniors. That's a different kind of question than part B. Again, I can divide this by 4, so this is 11 out of 19. 11 out of 19 seniors were attending the prom. That's different than saying something like 69 out of 160 students are attending the prom. 44 out of 76 seniors, 25 out of 84 juniors. That was a different type of question. So that's what I mean. These things around the outside may show up in denominators, not just the 160. The 160 is the denominator when you're saying, okay, we're going to randomly pick someone from this prom, from this entire situation. They could have come from anywhere. What's the probability that, whatever. Then if we're talking about selecting them from anywhere, yeah, it's out of 160. But this is different. Find the probability that a senior from the sample is attending the prom. That's different than find the probability of a randomly selected student being a senior who was attending the prom. That would have just been 44 out of 160. This is 44 out of a smaller pool because we were told we're only looking at picking a senior. Okay, we can convert the frequencies to relative frequencies if we just did this out of percentages. You can do this the same way. I could go above and I could divide, but I could also just look at this. If this is 100%, this is 43.1. I can figure out what this has to be. This has to be the rest to make 100% this way. Which is, okay, that's 44, 50, I think that's 56.9%. This is a nice subtraction. This is 20%. This adds up to 47.5%. So that means this better be 52 to make 100% straight down. And then back here, I could either subtract these, 43.1 minus 27.5, or I could go 52.5 minus 36.9. I should get the same thing. That I'm doing it this way. That's 28.6. I think this has to be, that's 33.6. I think this has to be 25.6. Is that right? Nope. Sorry, I did that wrong. It's 15.6, I believe. 15.6, 36.6. Yeah, that seems to be right. Okay. Now these percentages, these are all percentages of the 100%. So if you notice, all 4 of these numbers ought to add to 100%, the 4 in the joint frequencies. So this 20%, I mean, this kind of implies we're talking about a certain denominator. This was just number of people. And in some ways, this is kind of easier to think about. This is like, okay, 20% of what? Is it 20% of the seniors? Well, no. This is 20% of everybody. 20% of everybody belongs in this square, which represents seniors who are not attending the prom. 36.9% of the total number of people, of everybody, were juniors not attending the prom, etc. So these 4 blocks have to add up to 100. That's a little bit strange, but that's what that means. Okay, use this two-way frequency table to answer these questions. Find the probability that a randomly selected person. You know what? This is going to be a whole lot easier if I have these marginal frequencies figured out. So if they're not there, let's put them on there. You have room around yours, but I'm going to make that work for me. Okay, so smoking and gambling. Oh, this is a great example. Total. If you thought just the fact that we were talking about cards and probability and dice games wasn't gambling enough. Well, now it really is. Okay. We're talking about smoking. Really? Okay. So let's get the totals down here. If this is 152, this is 182. Let's have the total number of smokers up here is going to be 234. The total number of non-smokers is 97 plus 58. That's 155. So the total number of everybody here is 389. That's really nice. And then total number of gamblers is the ones, if we add up all the whether or not they smoke, that would be 249, I think. If we add up all the not gamblers, that's 140, and hopefully this adds up. Good, it does. Okay. So that's great, because these numbers in red now are going to be our denominators for stuff. Okay, find the probability that a randomly selected person in the group gambles. So of all the gamblers, we have a total of 249 gamblers out of everybody. I don't know if that reduces or not. It's going to bother me if oh wait, calculator's not open. Just a second. Well, turns out it doesn't reduce. Okay. Find the probability that a randomly selected person in the group, so out of 389. I guess that's a real telltale sign. They say randomly selected person in the group. Okay, great, it's out of this. If they said randomly selected smoker, then that changes the denominators. But randomly selected, just anybody in the group has to be out of this. Well, it could have been anybody. Neither gambles nor smokes. So does not gamble, does not smoke. That is what this 58 means. 58 out of 389. Does that reduce? 58 out of 389. Does not reduce either. Okay. Okay. All right. I made myself some more room here for part C and D. Find the probability that a randomly selected person in the group smokes, given that they do not gamble. All right, so this is asking if it's kind of like the seniors at the prom question a second ago. Given that they don't gamble, so we're talking about of the non-gamblers, and that's a huge part of this question. Within the non-gambling group, how many of those guys, what's the probability that you pick a non-gambler and they also smoke? Okay, so the non-gamblers, that means now we're just asking about, we just care about a new sample space now. It's just out of those 140. Within that column, what's the probability somebody in there smokes? That's 82. 82 of the 140 non-gamblers are smokers. I'm sure that reduces. 82 out of 140. It just divides by 2. I knew we did that right. So that's now the next one is find the probability that a randomly selected person smokes or gambles. Okay, randomly selected person in the group. So that's just that's out of everybody again. So that's out of 389. Smokes or gambles. Okay, smokes and gambles is this. Gambles but doesn't smoke is this. Does not gamble is this. It's kind of like they have to be in here or in here or in here. And so remember, or means add. So we're going to do on that one. I'll take these off so that won't look funny later. All right, so then it's really just 152 plus 97 plus 82 out of 389. I will definitely do that on the calculator. 152, 97. Oh, wait, that's 249, really, isn't it? 249 plus 82. 249 plus 82 out of 389. So 331 out of 389. Okay. Great. Oh, and that's it. Okay, I guess that's all there is to do. I will see you in class.